All right, let's take a trip. We're heading way out there, almost 2 billion miles from the sun, to meet the real weirdo of our solar system, the ice giant Uranus. It's time to explore one of the great unknowns right in our own backyard.
So what makes this planet so weird? Well, for starters, it's a planet of extremes. I mean, it's tilted so far over, it literally rolls instead of spinning. It's also freezing cold, colder than it has any right to be. And its whole history, it kind of seems like it was shaped by some seriously epic cosmic violence. So yeah, what exactly is going on out there?
Okay, let's dive into the first big clue. Probably the most famous thing about Uranus, the way it moves. You see, unlike pretty much every other planet, it doesn't just spin, it rolls.
Get this, 98 degrees. That is the bonkers angle of its tilt. Just to give you some perspective, right? Earth's tilt is a nice, gentle 23.5 degrees. That's what gives us our seasons. But Uranus? It's knocked over so far that it's basically rolling on its side as it goes around the sun.
Here's a great way to picture it. Most planets, they spin kind of gracefully, like a top. But Uranus, it's just barreling along like a bowling ball rolling down an alley. And you can bet that this completely bizarre way of moving has some truly wild consequences.
Yeah, for one, it creates seasons that are, well, they're almost impossible to imagine from our perspective here on Earth. This is not your typical summer, fall, winter, spring kind of deal. Not even close.
Because it's rolling sideways, one pole gets pointed directly at the sun for 42 years straight. Imagine a summer day that lasts for 4 decades. And at the same time, the other pole is thrown into complete darkness, a winter night that also lasts for 42 years. The whole trip around the sun takes 84 Earth years. So a single season on Uranus is basically a human lifetime.
Okay, so the planet's on its side. Super weird, right? We've got a theory for that. Don't worry, we're getting to it. But this is where the mystery gets even deeper. On top of all that, Uranus is also shockingly, almost unbelievably cold. We're talking a minimum temperature of minus 371 degrees Fahrenheit. That makes it the absolute coldest planet in the entire solar system. Colder than any other world we've ever measured. Let that sink in. And this is the part that really messes with scientists' heads. You're probably thinking, but wait a minute, isn't Neptune farther from the sun? And you'd be right. It's a whole billion miles farther out. Logically, it should be way colder, but it's not. That's right, even though it's a billion miles closer to the sun's heat, Uranus is colder than Neptune. It just doesn't make sense. What this tells us is that unlike other big planets that churn out a lot of their own internal heat, Uranus just isn't. It's like its internal engine has shut down. It's a cold, sleeping giant. So now we have 2 massive mysteries on our hands. Why the crazy tilt, and why the extreme cold? So, what could possibly explain both of these things at the same time? Well, the leading theory is pretty dramatic. It all points back to a single cataclysmic event, way back in the planet's chaotic childhood. I mean, what if these 2 totally bizarre facts, the tilt and the cold, aren't 2 different problems? What if they're actually 2 symptoms of the exact same ancient injury? The answer, scientists think, was a giant collision. We're talking about a massive impact, billions of years ago. The theory goes that when Uranus was still young, it got slammed by something huge, an object at least the size of Earth, maybe even bigger. And amazingly, this one single violent event could explain everything. First, the impact. The sheer force would have been enough to just knock the whole planet over. Boom! There's your 98-degree tilt. But here's the other crucial part. That collision would have essentially cracked the young planet open, letting all that primordial heat trapped deep inside its core just escape into space. And with its internal engine gone, Uranus was left to cool down to the freezing temperatures we see today. It's a 1-2 punch. And you know what? The evidence of this ancient smash-up is everywhere you look. It's not just the tilt and the cold. Uranus is home to a whole system of other strange and fascinating features that all seem to point back to that one event. For example, you think of Saturn when you think of rings, right? Well, Uranus has rings too, 13 of them. They're just really dark and thin, so they're hard to spot. It also has a whopping 27 moons, and they're all named after characters from Shakespeare and Alexander Pope, which is pretty cool. And to top it all off, even its magnetic field is all messed up. It's tilted and way off center. It's just another giant clue screaming, something crazy happened here. And speaking of moons, one of them, Miranda, is especially wild. It honestly looks like it was shattered into a million pieces and then just sloppily glued back together.
It has these massive cliffs on it. One of them is thought to be the tallest in the entire solar system. If you were to fall off the top, it would take you over 10 minutes to hit the bottom. It's just this incredible, stark reminder of the violent forces that shape that whole system.
So with all these incredible mysteries, all these questions, you'd think we'd be all over exploring Uranus up close, right? Well, the answer, unfortunately, is not really. Not much at all.
Ever since it was discovered way back in 1781, only one spacecraft has ever visited. Just one. That was Voyager 2, and it just did a quick flyby way back in 1986. Think about that. Almost everything we know, every close-up picture we have, comes from one brief visit decades ago. If we ever want to confirm that giant impact theory and really understand this bizarre world, we absolutely have to go back. And this is really why it matters so much. See, Uranus isn't just some local oddball. Planets like it, these ice giants, are now thought to be the most common type of planet in the entire galaxy. So figuring out our own weird, tilted, frozen giant isn't just about Uranus. It's a critical key to understanding thousands, maybe millions of other worlds out there. It makes you wonder, doesn't it? What other cosmic stories, what other giant collisions are just waiting for us to discover?